Today is day 8. We're going over independent and dependent variables. The objective is you will be able to identify the independent and dependent variables in an experimental investigation. For warm-up, we were going over how to read a graduated cylinder. You can view this in Canvas. To reiterate off of that video, just make sure that the proper way to read a graduated, going off of the video, to review from that video, make sure when you are reading a graduated cylinder, you are reading it the proper way. Your eyes should be level with the top of the liquid in the graduated cylinder. In other words, you should be reading the water level at eye level. You need to be aware of the meniscus. Remember, the meniscus is the curve that you see at the bottom when you're reading the liquid. You're going off of the bottom of that curve, not the sides. Another thing to be careful about is in between each big number that's shown, you're counting by 1. So it's 61, 62, 63, 64, 65, 66, 67. So this eye level, reading this at eye level, you would determine it was 67 milliliters is where the liquid comes up to. Not 68 or the sides to 67. And you're going by 10. You just need to make sure you pay attention to the scale. All right, we're going into our identifying the variables. I'm sure some of you are wondering, what is a variable? Well, a variable, this is any factor, trait, or condition that can exist in differing amounts or types. Basically, it's just the parts of an experiment. If we're determining in an experiment over if plants are going to grow in the sun or in a closet, a variable is the plants itself growing. Another variable is putting it in front of the window, and the other one would be putting the plant in the closet. It's just the parts of an experiment. And an experiment usually has 3 kinds of variables: independent, dependent, and controlled. We will get into these in more depth. Today we're only going to focus on independent and dependent variables. So, focusing on these two. First off, an independent variable. This is a variable that is changed by the scientists, the eye control variable. If we were measuring 2 plants and seeing which one grows, the things we are controlling is if a plant is in front of a window or if it's in a closet. The dependent variable, this is a variable that might change because of what we are changing as a scientist, what is being measured. We're measuring the growth, and it's going to change depending on whether or not we put the plant in front of a window or we put it in a closet. This is just a table contrasting independent and dependent variables. Independent variables, this is what I change. Again, in contrast to a dependent variable, this is what is being measured. The independent is what we are testing. We would be determining, if whether or not a plant can grow better in front of sun or in front of a closet. And the results would be how high the plants got or how much they grew. The effect would be the plants growing. The cause of the plant either not growing is because it was in a closet, or the effect being the plant did grow because it was in front of a window. The input and the output. The independent is just a thing that is different in each group. Independent variables would be the window or the closet, and the dependent is the data you are collecting. So the first example, kind of similar. Is plant growth affected by the color of light in which it grows? So to tell if light affects plant growth, we're going to put 3 plants underneath 3 different lights that are different colors, one red, one yellow, one blue. The light color is what we are testing. That is the independent variable. It's what we're testing. So we have different groups. It's the thing that is different. The colors. We have a red, we have a yellow, we have a blue. The dependent variable is what depends on the color. So the plant growth is going to depend on which color light that the plant was underneath. It's a result of the experiment. Here's our first example. If I drink Mountain Dew before bed, then I will not sleep very much. In this example, our independent variable is drinking Mountain Dew. Why? Because I can control whether or not I drink Mountain Dew. I can control how much Mountain Dew I drink. That is the thing that we are controlling in this experiment. The dependent variable is the amount of sleep you get. If I don't drink Mountain Dew, I'll probably go to sleep better, have a very good night of sleep. If I do drink Mountain Dew, then I'm not going to get that much sleep because soda is going to probably run up my heart rate and make me very hyper. So that's an example. Here's another one. If I leave all the lights on all day, then my electric bill will increase. We're going to look at what we can control and what the result would be. So first off, what can we control in this experiment, in this hypothesis? Well, we know we leave the house. We control if the lights are on or not. So we know that's our independent variable. Now, whether or not we left the lights on, that's going to affect the amount of our electric bill. If I leave the lights on, my electric bill is probably going to run really high. If I leave the lights off, my electric bill is going to be relatively low. So let's get into more guided practice on this. So in these slides, we're just going to go over more examples so you can try to get the hang of identifying independent and dependent variables in a hypothesis. Our first hypothesis is if I brush my cat more, then there will be less fur on my furniture. In here, what is the action? We're brushing a cat. That is the thing we are controlling. Therefore, that is the independent variable. Now, the thing that depends on brushing a cat is getting the fur on the furniture. So the result, if I brush my cat more, there'll be less fur on the couch. That's the dependent variable because the amount of fur on the couch is going to depend on how much I brush my cat. So just remember, independent variable is what you can control. You can control how much you brush your cat. You can't control how much fur it sheds on the couch. That's why brushing your cat is the independent variable. We are measuring how much fur gets on the couch. That's what makes this dependent variable because it's a measurement. Does the type of oil affect the size of popcorn? This one we have to look at. First, I would just like to look at, well, what's the thing we're measuring? If we're measuring something, we're measuring the size of something. So we're going to look at this, size of popcorn. If I think of that, my dependent variable, knowing that's the measurement, that's the result of something, I automatically know that the size of popcorn is my dependent variable. Therefore, that's going to depend upon my independent variable, which is going to be the type of oil. If I change up the type of oil, that's going to affect the size of my popcorn. Makes that the dependent variable. So we can't control the popcorn size, but we can control what type of oil we use. So that makes that type of oil, again, the independent variable. Does the amount of rain affect how high the grass grows? So this might look like a little trick question, but again, if we're going to measure something, we know that's the dependent variable. We're measuring something. What's the thing we're measuring? We're measuring how high the grass grows. So we automatically know the grass height is our dependent variable. Therefore, the amount of rain is going to be the independent variable. Can we control the amount of rain or how high the grass grows? I can't control either one, okay? I know that's why I said it's kind of a trick question, but we just need to look at the cause and effect. We know if it rains more, the grass is going to grow high. If it doesn't, it's going to go pretty low and turn brown, which is the cause and which is the effect. We know that the cause is the amount of rain, the effect would be the grass growing. Again, here's reiterating what we've already learned. If I leave all the lights on all day, then my electric bill will increase. Things we can control is the lights being left on or not, and that's our independent variable. Things that would be measured would be the electric bill, making that our dependent variable. Elizabeth wanted to test if temperature affected how fast milk goes bad and curdles. She left milk in a room temperature closet of 70 degrees, a fridge of 40 degrees, and an oven that was 100 degrees, turned on low heat. She then checked each milk every day to see how long it took each milk to go bad, or in other words, curdle. So in this situation, what I would always tell you guys is just to try to find things you need to know. What is the experiment? Well, if you look, the experiment is that Elizabeth, she wanted to test if temperature affects how fast milk grows bad. That's the experiment. So from there, we can look at, well, which one is she controlling? We go deep within that paragraph, we see she's controlling the temperature. So if she's controlling the temperature, we know the temperature is the independent variable. What's going to depend upon temperature is how fast that milk goes bad. So that is what's being measured, how fast it goes bad. So I hope you guys have more insight and got the hang of identifying independent and dependent variables within a hypothesis. As of right now, just go to Canvas, complete that independent and dependent variable exit ticket. You're going to be telling me which one is easier for you to identify and why. You can access the link through Intro to Day Science, Day 8, Intro to Science Day 8 page under Independent Dependent Variables. If you have any questions, please let me know. After you've done that, please do your independent practice over independent and dependent variables. Again, same page, you can access the link. Contact me if you have any questions. Don't freak out because it's a quiz. That's letting me know, but you know. And take it easy.